In the last video, we took a look at the definitions of the inverse sine, inverse cosine, and inverse tangent. I now want to look at the other three. But something I want to notice here. Recall that the secant, let me go with the cosecant. Recall that the cosecant of theta is 1 over the sine of theta. That is, the ratio of sides that you get out of the cosecant is the reciprocal of the ratio of sides you get out of the secant. Okay, I'm going to use this to my advantage. In fact, if I take a look at, I want to look at what is cosecant inverse of x. Right? I want to draw a picture. Now, this is a trig class, and so you might expect that the picture that I'm going to draw is a triangle, and that's indeed the case. I want to draw an angle here. Right? Remember, inverse trig functions take a ratio of sides in, and they give you an angle out. So when I say I want to draw a picture, I got to draw a bigger one. When I say I've got the arc sine of x, I've got the inverse, cosecant. I've got the inverse cosecant of x. I've got the angle whose cosecant is x. I'm talking about an angle here, right? This angle right here is going to be the cosecant inverse of x. So I want to put some sides on this right triangle so that I guarantee that this angle has a cosecant equal to x. Well, the cosecant is the hypotenuse over the opposite side. So if I make this x and this 1, then yes, indeed, the angle right here has a cosecant equal to x over 1. So it is the inverse cosecant of x over 1. Right? It is also the angle whose sine is 1 over x, is that angle. I can think of that angle two different ways. It's the angle whose cosecant is x over 1. It's the angle whose sine is 1 over x. Right? Cosecant inverse of x is equal to the sine inverse of 1 over x. Right? Up here, there's a relationship between cosecant and sine, right? That the cosecant function is the reciprocal of the sine function. Remember, the output of this is a ratio of sides. The output of sine is a ratio of sides, and I'm saying those ratios are reciprocals of each other. Here, I'm talking about angles. The output of the cosecant is an angle. The output of the cosecant inverse is an angle. The output of the sine inverse is an angle. The angles aren't reciprocals. The ratios of sides are reciprocals, and the ratio of sides go on the inside. So if I'm plugging an x into cosecant inverse, then I should be plugging a 1 over x into sine inverse. So on your calculator, if you ever try to calculate what's the cosecant inverse of 3/5, right? Your calculator doesn't have a cosecant inverse button. It has a sine inverse button. So you type into your calculator, I want the sine inverse of 5/3. You just take the reciprocal of the input, right? Because the cosecant inverse of 3/5 would be this angle right here. Cosecant inverse is no good. We got a problem here because the sine is never 5/3. Right, that's too big. So let me back up a moment and flip that over to start with. Cosecant might be 5/3 for an input. And so the sine would be 3/5. Okay. So the picture looks like this. This angle right here might have a cosecant of 5/3. This is the angle whose cosecant is 5/3. It's also the angle whose sine is 3/5. Right? This angle described two different ways. Something important came up here. The input to the cosecant has to be bigger than 1 or less than -1. Right? And the inverse cosecant graph, I think I'm just going to switch to the book and show it to you. There's the inverse cosecant graph. Right? When x is negative, you're getting negative angles again. That again, you're in the fourth quadrant. So between negative pi over 2 and 0. For positive inputs, it's giving you angles between 0 and pi over 2. So like the sine, the cosecant, like the sine inverse, the cosecant inverse is giving you angles between minus pi over 2 and plus pi over 2. Right? Likewise, there's a similar relationship between the secant inverse and the cosine inverse. Right? Switching back to here, the relationship is that the secant of an angle is 1 over the cosine of the angle, right? Again, this is a relationship between ratios of sides. They're reciprocals. The angles aren't reciprocals. The ratios of sides are reciprocals. So when I look at the inverse secant of x, this should be the inverse cosine of 1 over x. Again, the picture that I draw here is a triangle. That this angle right here, if I make this side x and this side 1, then this angle I can think of either as the angle whose secant is x divided by 1, or I can think of it as the angle whose cosine is 1 divided by x. Both of these things are the same angle. The angle whose cosine is 1 over x, the angle whose secant is x. Right? Lastly, the inverse cotangent, right? There's a relationship between tangent and cotangent, which actually I want to write this way, that the cotangent of theta is 1 over the tangent of theta. Outputs are reciprocals. Ratios of sides are reciprocals, not angles. So when I look at the inverse functions, the inverse cotan of x, that should be related to the inverse tan of x, but it's because of the reciprocal property on the inside, right? Because the input here is the ratio of sides, the output is an angle. I don't want in reciprocal angles, I want reciprocal ratios of sides. The picture for this is that I'm talking about this angle here. If I call this x and this 1, so that this angle right here is the angle whose cotangent is x divided by 1. It's also the angle whose tangent is 1 divided by x. Right? So there you go. I think first and foremost of the 3 trig functions, inverse sine, inverse cosine, inverse tangent. I then use those to do the other 3 by taking the reciprocal of the input, right? Not the reciprocal of the output.